Hello and welcome to another one of D's ADD videos. Today we're going to be looking at linear regressions. The basic concept is that you're going to be looking at a scatter plot of data, and from that scatter plot of data try to estimate the best fit line for that data. In other words, the line that best represents all this data. Since it is a straight line, it'll have the form of y equals mx plus b, where m is your slope and b is your y-intercept. Some books have this as b1 and b0. Try not to confuse things with extra variables if it's not necessary. But how do we find these things? So that we can have a model that can accurately predict for any given x value. After you get this equation, you will then get a rough idea of what the corresponding y value would be. That's the whole point of a linear regression line. You're trying to see what the trend is. Alright, so how do we find these things? B1, M, whatever you want to call it, the slope of your line, is going to be your covariance over the variance of x. In other words, so this will be step one. After you find the slope of your line, what you're going to do is you're going to find the y-intercept. In other words, you're going to find either b0 or b, whatever you want to call it. The way you do this is if you rearrange that equation above, the y equals mx plus b equation, and I'll be nice, I'll do it for both equations just in case you have this book. It decided to come up with its own variable for slope. What you're going to do is you're going to look at these as the means, and you're going to solve for the y-intercept. And if you subtract that mx or bx over, wow, excuse me, sorry, since this is a rough draft video, it will be staying with the sneeze. I apologize for that. I don't think I had the heater high enough last night. Alright, so where was I? I'm solving for the y-intercept. Whatever equation you feel more comfortable using, go ahead and pick it and stick with it. Okay. Either way, it's the same equation. People use different variables in different textbooks and end up confusing students. Unfortunately, just if you understand the concept instead of trying to memorize formulas, it's a lot better. So this is the y-intercept. Okay. So you're gonna. Hopefully you found the means whenever you were finding your covariance and your variance. So you're going to use those means to plug into equation above going to solve for your y-intercept. And after you've done that, then you have found your linear squares coefficients. So if you see that, that's what they're asking you for. Is your slope and your y-intercept. They might ask you to find the equation. Just plug into your y equals mx plus b, or y equals b1. So the concept is, once you have this equation here, what you can do is you can plug in any x value. Sorry. See that, you guys? Even when I'm not feeling well, I'm working hard for you guys. Alright, so you plug in your x value and you can get a y value in response. And that's the point of that. So you can have the best fit line that accurately represents the data as best as possible. Alright, so just in case you forgot some of these equations, the covariance equation, actually I think the book probably uses I don't want to confuse people. So each data point minus the mean, or the average, for the x's, and the same thing with the y's. The data point for the y minus the mean for the y is the mean for the x. All over, because this is a sample, n minus 1. And then the variance formula, whether it's for x or y, in this case it was for x. Pretty much the same thing above, but since it's just one variable, instead of taking that deviation, that's what this is, I'm writing deviation, and multiplying it times another deviation, you just square it. It's all over like on this one. Guess it should be in the number too. Okay. And you should definitely know how to find mean by now as a statistics student. If you don't, make sure it's learning the formula for variance, aren't I? Wow. I might have to get some micro or something here. It's the sum of the data points over the total. And if it's y, alright, so recap. We're trying to find the equation of a line that best fits all the data so that we can predict, given an x value, what we get for y. Steps: find your covariance. If you've forgotten how to do that, check out the video for covariance. After that, find your y-intercept, then you found your means by now, so you can plug them into this equation and solve for your b or b naught, whatever you want to call it. Then after you do that, you found both your linear squares coefficients, your slope and your y-intercept, and then you can plug into your y equals whichever one of these two blue equations that you choose. And then after that, you're done. And you can plug in any x value they'll ask you to plug in, and then you can predict what y is based off of that, and then compare it to what it actually was if you have real live data. Is it above or below what you predicted? Alright, I hope that has clarified any confusion that you might have on the concept of linear squares regression, linear regression. Please check out the example video. Thank you and have a nice day.